Okay, for this problem, 3 dice are rolled. The first has 2 red faces and 4 green faces. The second has 3 red faces and 3 green faces. And the third has 4 red faces and 2 green faces. What is the chance of getting 1 red and 2 greens? For the first part of this problem, the probability of getting 1 red and 2 greens, there's no really elegant way to do this except by just simply listing out all the possibilities. You could have red on the first, green on the second, or green on the third. Another possibility is green on the first, red on the second, green on the third. And the third possibility is green on the first, green on the second, and red on the third. Now these are mutually exclusive events, and so that means we can just simply add up these 3 things. So we'll write this red on the first, green on the second, green on the third, plus green on the first, red on the second, green on the third, plus the probability of green on the first, green on the second, red on the third. Now how do we figure these 3 things out? Well, these are independent dice, and so we can multiply the individual probabilities. The chance of red on the first is 2 out of 6. The chance of green on the second is 3 out of 6. And the chance of green on the third is 2 out of 6. Next, the chance of green on the first is 4 out of 6. The chance of red on the second is 3 out of 6. And the chance of green on the third is 2 out of 6. Finally, the last possibility, chance of green on the first is 4 out of 6. The chance of green on the second is 3 out of 6. And the chance of red on the third is 4 out of 6. And so then it's just a matter of simplification, and if I did the arithmetic right, I believe the answer is 7/18. For part B of the question, suppose that you know that there is 1 red and 2 greens. What is the chance that the third one is the red one? So writing this out in the language of probability, that's the probability of green on the first, green on the second, red on the third, given that exactly 1 is red. And so that's this long union that I'll rewrite here. Okay, by the definition of conditional probability, that's the probability of the intersection of these 2 events. So the first event intersected with the second event. Divided by the probability of the second event. Green 1, red 2, green 3, and green 1, green 2, red 3. Okay, now the first one is silly, if you think about it. This is a part of this union. So this right here, G1, G2, R3, that is part of this union. So this set is a subset of this bigger set. So if I take the intersection of this smaller set and this bigger set, which includes the subset, when I take the intersection will simply be the first smaller set, divided by the probability of the bottom. Union G1, R2, G3, union G1, G2, R3. Okay, then it's just a matter of computing these things. The probability of green on the first, green on the second, red on the third, that's exactly this third piece here. 4/6 times 3/6 times 4/6, divided by the bottom, which we already figured out to be 7/18. And then if I did the arithmetic correctly ahead of time, this simplifies to be 4/7. And we get an answer that's bigger than a half, and if we think about it, it makes sense because the third one has the most possibilities of being red, so it stands to reason that this one ought to be the larger if I were to do the same kind of calculation with either the first or the second terms.